Nature is the ultimate designer, and incorporating nature-inspired designs into coastal infrastructure can provide maximum resilience, as well as economic, environmental, and social benefits. However, doing so has been difficult because of constraints in traditional manufacturing. Rapid advancements in additive manufacturing and pioneering research by the U.S. Army Engineer Research and Development Center, or ERDC, have opened new possibilities. Looking to capitalize, a team at ERDC is studying how 3D printing can create geometrically complex structures needed to mimic nature. As an added first-time innovation, this Engineering with Nature, or EWN, project beneficially uses dredged material as feedstock for the printers.
In the environmental laboratory, we've been looking at additive manufacturing for the past 5 years to understand the health and safety of potential ultrafine emissions, as well as printing structures that can potentially remove contaminants from water. But the innovation of this particular Engineering with Nature project is that we noticed that a lot of the habitat infrastructure that's deployed in the environment are very simple geometries, like cylinders and cubes. We felt that additive manufacturing can add innovation and nature-inspired design to a lot of these structures that could better serve our coastlines, the Army Corps of Engineers, and the nation.
You are able to print more complex geometries with 3D printing and additive manufacturing. It allows you to do things that traditional manufacturing, subtractive manufacturing doesn't allow you to do. And so you can get these very complex structures that look more nature-inspired, such as with the mangrove roots, or other habitats such as bird nests that aren't traditionally available with subtractive manufacturing.
What's really fascinating about 3D printing and additive manufacturing is there's a myriad of opportunities here to integrate this into nature and provide ecological benefits and also social and economic benefits. And some of those targeted benefits that we're pursuing is habitat restoration, where we can actually take this material and improve habitat that may be degraded or destroyed.
The Chief of Engineers has a goal to increase our beneficial use of dredged material from 30% to 70% by the year 2030. It became clear to us that we could start using sediment as a resource to create a paradigm shift from it's a waste material that needs to be disposed of to a clean environmental resource that can be used on-site, on demand, where it's needed, to 3D print nature-inspired design for coastal resilience, habitat restoration, and habitat creation.
We have a long history of toxicology expertise with the environmental lab, and we know the vast majority of these dredged materials are clean. And the little bit that isn't, that has some contamination in it, through our methods, we're working on developing ways to sequester it.
This cross-disciplinary effort benefits from the expertise of multiple ERDC laboratories. The Environmental Laboratory is leading the project in its conception and studying the features and geometries most relevant for 3D printing as habitat. And the Coastal and Hydraulics Laboratory will perform hydrodynamic modeling of the resulting structures. Meanwhile, the project also benefits from the additive manufacturing expertise from both the Geotechnical and Structures Laboratory and the Construction Engineering Research Laboratory. Researchers from these labs are applying knowledge to explore the possibility of large format prints using dredged material directly in the field.
Large format in general is just like smaller scale printing, or at least our facility here, where you deposit a layer, but we can do it much bigger, and that gives us the capability to manufacture much larger parts faster than you could do it with traditional manufacturing, and it gives us a lot more freedom in the designs that we can do. So we wouldn't be able to produce the parts that we would want to that are nature inspired with traditional manufacturing, but we can do it with additive.
We've spent a lot of time in recent years using a lot of military engineering projects that are focused on what we call manufacturing at the point of need. So being able to produce something there as close as possible to where it's actually being needed instead of like a factory and then shipping it out. But being able to take that and then putting that there, like say on a shore side, and then pulling dredge material from that, running it through some robotic system or whatever, and actually being able to print there on site would be massively beneficial for a whole lot of reasons.
As this research begins to explore the use of additive manufacturing to print nature-inspired infrastructure using natural feedstock building materials, ERDC hosted a workshop with government, industry, and academia in February 2024 to foster further collaboration and spark innovative ideas. The workshop included a diverse group of subject matter experts in the fields of material science, toxicology, ecology, mechanical engineering, chemical engineering, landscape architecture, social science, and dredging technology.
What excites me the most about this new project where they're looking at 3D printing dredge material is it's really taking advantage of everything that we think about when it comes to engineering with nature. The opportunity to use local materials, use our principles of engineering to sort of improve the performance of both ecosystem and ensuring safety of the coastline, and doing that in a way that contributes back to the ecosystem. That's really exciting. It's this really beautiful opportunity for advancing processing, manufacturing, materials science, and the ecosystem in which we work in.
What excites me the most about bio-inspired architecture and bio-derived materials is that nature has spent about 1 billion years optimizing structure. Humans have only been around doing technology for, well, not 1 billion years. So we get to really learn from nature and how to make better structures. This workshop brings people of different backgrounds and interests all together, and we get to work collaboratively to solve the problems that need to be solved that we've identified.
What's extremely exciting is it seems like we're only limited by our own imagination. So one of the things that we're targeting in this project is actually bringing subject matter experts together to hopefully inspire each other and inspire some designs to use 3D printing to improve all these things that we're talking about.